So now let's move on to some other new features in this release. We're here on the Image File tab. I'm going to select a different image. Now, there's not much there yet, is there? This is a great example of how the Histogram Stretch can help you. Let's open it here and select a stretch for the entire image. And then I'll click on Auto Stretch. Aha, there are a lot of stars in Spectra that popped into view. And as I mentioned a moment ago, we've re-engineered this Histogram Stretch window so it's much, much faster in this release. You can even stretch the entire image when using live video. That'll be a big help when acquiring a target. The stretch is also more accurate now because we don't have those black borders to contribute extra dark pixels anymore. For the best results with the Histogram Auto Stretch, it's always a good idea to narrow the capture region down to a specific area that you're studying, like I'm doing here. We'll select an overly wide region for the purposes of this example. Now I'll turn off the entire range checkbox and click Auto Stretch. Wow, look over here. We can see two different emission spectra, one here and one there. These are two Wolf-Rayet stars in the same field, captured on a C8 with just 40 seconds of exposure at a dark sky site. And glancing over here, we can see that their features seem to be a little bit different from one another. So let's take a quick detour to remind ourselves how easy it is to process these. I'll bracket in the first spectra, and then I'll click on the Calibrate button. Then I'll zoom in and click just for a rough calibration to save time on the peak. And then, because I previously calibrated my telescope, I can use one-point alignment using the dispersion that I determined previously. Once I've done that, I click Apply, and I can close this window. I double-click to zoom out, and there's our calibrated and angstrom spectrum. Let's open the Elements window and come down here to the Wolf-Rayet WC carbon type element lines, and then shift left click to zoom in. Wow, look at the match between the reference lines in blue and our data. And in fact, if I hover over these two blue lines, we can see that they are carbon emission lines. They're broadened by the intense stellar winds on this Wolf-Rayet star. So isn't that amazing? I'm not going to take the time to calibrate the second spectrum, but if you want to try it yourself, this FITS image file was installed during the update in this folder here. So let's close the Elements window, and I'll load onto the profile graph a calibrated version of that second Wolf-Rayet star. I calibrated this earlier in the day before we made this video, just so we could look at it here. There the two are, and you can see they really do have a different set of spectra features. These two carbon peaks we saw earlier really don't appear in the blue. Now, one of the things we can do is use this toolbar button to adjust the relative height to make it a little easier for us to compare the two. So in this field of view on the left, we have two Wolf-Rayet stars, and they have different spectra. Wolf-Rayet stars are fascinating targets. Here we've seen how quickly we can calibrate them in RSpec and how they can differ so much from one another. It's these kinds of spectra that are so exciting because they can encourage us to do more reading on the web to learn the physics behind them and the history of their discovery. Okay, let's get off that detour and back to the new features in this release. So here I've closed that reference spectra and I've double-clicked to zoom all the way out on our two spectra. Oftentimes when working with spectra, we find ourselves needing to zoom in to look at just a given region like I've done here. Suppose we wanted to discard the right-hand spectrum that's just disappeared from view. We've zoomed in, and now I can click on this new toolbar button to delete all of the points that are outside of the current view. I clicked yes, and now it looks the same, but there's no other points that we can pan to the left or right. So that's cropping. I'm going to open a Vega image here to look at something else. Let's quickly do a two-point calibration after bracketing it in here. I'll click on Calibrate. There's the zero order. And again, we're going to use two-point alignment, so we'll turn that off. There's the hydrogen beta feature, so I'll click on that after positioning in that field. Now, once I've done that, in the past I had to type in that hydrogen beta wavelength, but because it's so frequently used here, we've added this checkbox that will fill in that wavelength, in this case 4861, in one click. Again, just something to speed up, something that one of our users suggested. Thank you. So here's something else that's new. If you're using a slit spectrometer, you may have the need to splice two spectra side by side. I'm going to use a low resolution spectrum in a contrived example so it's easier for you to see here. Suppose I have two spectra that I want to splice. So I've prepared two different spectra that we want to splice here. There's the first one. It's the left-hand side of a low resolution spectrum. And now what I'm going to do is click on reference and load the other spectrum I want to splice onto the reference series. Now there's a single curve. It's two different colors because it's two different graphs. So what I'm going to do is click on the Math on Two Series menu option. This new option here allows me to splice the two into one profile line when I click Calculate. There, now it's one curve. I'll clean up the screen over on the right to make it a little easier to see what's about to happen, and then copy it back to the main profile. So now we've spliced it. So it's a single curve. Now, one hint, the profile on the left here always has precedence. Overlapping points from the second profile on the right are discarded. So now there's another way to do a splice like this. Why? Well, frankly, I wasn't sure which one users would find easier to use. First, I'll close the math window and then jiggle the orange sampling lines to clear the graph so you can clearly see what's going to happen. So to splice those two pieces of the low resolution spectrum that we saw a few minutes ago, click on the Open button and open them both. Hold the Shift or Control key down and select there's one and there's the second and click OK. Now they both got loaded and spliced together into the single profile line. Looking at it now, it looks like this second way is much easier if you've already saved this spectra to the disk. Here's another new feature. I've turned on the measure lines and bracketed in a region, in this case a zero order star. Down here is a new field that shows the area under the curve between them. This is for some specialized processing that only a handful of users might want. So let's calibrate this again. I'm going to click Calibrate and Reset to go back to pixels and close because I want to show you a neat trick. If I hold the Shift key down and click Calibrate, you can see we flip to angstroms. How did I do that? Well, let's open the calibration window for a moment. When you shift-click on the Calibrate button, RSpec reloads whatever calibration you most recently saved with this button. It's a handy trick when you're reloading the same calibration you used most recently. But remember, you've got to save it first before you use that shift-click. There it is. So I'm going to pop up the reference library here and slide it over to the side. In the past, when we clicked on a star type, the entire reference spectrum appeared like this. But all of these points here are outside our visible observing wavelengths. So in many cases, we may not need them. So this new checkbox here will automatically crop to just the visual region, like that. So now as we scroll through the reference library and the different blue curves show up for the different star types, the profile graph shows only the visible region, making it far easier to work with. So let's talk about the BESS database. It's a curated ProAm catalog of spectra, many of which have been contributed by amateur astronomers. RSpec can now create the 1D FITS files that databases like the BESS database require. It's beyond the scope of this video to discuss the kind of spectra and the processing and preparation details that databases like this one and any others that may come online require. You'll need to check with the database administrators to determine what contributions they accept and how you get validated for submitting spectra. But let's take a look at how we use it here. We click on this down arrow and we select Save Profile to 1D FITS file. On this screen, you select the details like the observer, the site, the object, and so forth. Once you've completed this tab, you can move on to the Advanced tab, and here's where you can enter optional information that's specific to the particular database you're submitting to. So you'll need to confer with the database administrators to determine how to submit this information to their sites. So back here on the main screen, a few final things to wrap up. I'm going to open a raw image file of Pollux taken on a DSLR. This header button up here has always shown the FITS file headers. It now shows the header of almost any file type. Let's click on it. Here, for example, is the header of the current image, which is a raw image. Because the sort checkbox has a check mark, this data is sorted with these often used fields at the top for easy access. The Customize button will allow you to sort additional fields to the top if you like. Okay, finally here on the Tools menu, Create Video, we've added this video encoder option so you can encode videos in whatever codec you're using. Now, there's been an important bug fix. Some users experienced a problem with the wavelengths of customized labels here on the appearance screen. That would be these fields here. They weren't being properly read from a saved layout, and that's been fixed. And although it's a bit esoteric, if you have a floating window like this one, and you've dragged it over to a second or third monitor, like this, when you restart the software will now properly put it back on that monitor from which it came. So once again, I'd like to thank all of you for your ideas, your support, and your encouragement. I really appreciate all of your input, patience, and ideas. All the best.